What's up guys, welcome back to the channel. In this particular video I will explain the problem form a number divisible by 3 by using array digits. Well, this problem is really interesting and based on number systems, so make sure you stay tuned till the end of the video. Starting with the problem statement, so it basically says that you will be given an array ARR of integers of length n. You can construct an integer from two integers by treating those integers as strings and then concatenating them, right? So example is given here. Let's say I have two integers 19 and 4. So there are two possibilities. Either I can write 19 and 4 like this, I can write 194, or I can first write 4 then 19. So it is basically going to form 419, right? Now, the task is to find whether it's possible to construct an integer using all the digits of these numbers such that it would be divisible by 3, right? And now, if it is not possible, then you can simply return 0. If it is possible, then you can return 1, right? Now, guys, see, one example is given here. For this example, I have an array which contains 40, 50, and 90. Now for this particular array, guys, there are multiple possibilities like how we can combine these numbers. Like this is basically writing all the permutations, right? So I can first write 40, then I can write 90, then I can write 50. This is one of the possible permutation. Or I can first write 50, then 90, then 40. So there are multiple possibilities like this. But see, how we can check if a number is divisible by 3? So if you guys are aware of number systems topic in mathematical concept, so you will be aware of the divisibility rule of 3, right? It basically says that if the sum of all the digits is divisible by 3, then the number is divisible by 3, right? So what we can do is we can pick any number, then we can simply sum up all the digits, right? So I have 4 plus 0 plus 9 plus 0 plus 5 plus 0. So this is nothing but 9 plus 5 14, then it is 18, right? And 18 is divisible by 3, so it is sure that this particular number will be divisible by 3. So what we can do is we can form this number and then we can simply return 1 as the output, because we are able to form a number, right? This is what we need to return. Now this is about the problem statement. Now I hope problem statement is clear to you, so let's talk about the solution now. Okay, so guys, first of all, I'm going to write the same example which is given in the problem statement. So it is basically an array which contains the element 40, then 50, then 90, right? And see guys, first of all, I want you to understand the divisibility rule of 3. It basically says that if the sum of digits is divisible by 3, then the whole number is divisible by 3, right? So for example, let's say I have a number 40, 50, 90. So sum of digit is basically going to be 18 here, right? And now if I permute this particular like these particular numbers, so more numbers I can form, like I can write 90 then 40 then 50, or I can write 40 then 90 then 50. But there is one interesting observation that we can make is the sum of digits is going to remain 18, right? So this basically means that doesn't matter how we permute the numbers, right? So we can form any number, but what we care about is the sum of digits, right? So first approach basically says that we can we can find the sum of digits of like all the numbers, then ultimately we will have all the sum of digits which are given here in any of these numbers, and once those sum of digit is divisible by 3, then the whole number is divisible, right? And we can simply return 1 as the output. How it is going to work, let me explain. So first of all, what we can do is we can basically iterate over every element in the array, right? So we have three numbers for this particular array, so I'll say that for num in ARR, right? And for every number, guys, first of all we can find the sum of digits of that particular number. So let's say initially my sum is equal to 0. For this you can see that we have 0 as the second number, but we can have 38 as well, right? We can have 38, and for this the sum of digit is going to be 11, right? So first of all we have to find the sum of digits. So how we can do this? We can simply initialize s equals to 0 for initial, and while my num is not equal to 0. So we will keep dividing the number by 10. For example, we have 38. So first if I divide this number by 10, so I will have 30, right? I will have 3. And this 8 we have to extract out. So I'll say that, okay, n equals to num mod 10. So this is something which will give me 8. And I'll simply say that s plus equals to whatever this n is. So initially this n is 8, and now I want this number to be 3, right? So I'll simply divide this number by 10, and num divide equals to 10. So this is how we basically find the sum of every digit in a number, right? And now you can see that it will become 3 in the second iteration, and then we can simply find out the sum of digits. So it will first add 8, then it will add 3, and 8 plus 3 is nothing but 11, right? So this is how we can get the sum of digit for every number. Of course, we don't have 38 in this particular array, but I'm using this just to explain you guys, right? And now once I have got the sum s, so I can simply add it to my ultimate sum. So I'll say that sum plus equals to s, and what this will do is this will first give value 4 for this particular like number, like, right? And after this I'll go to this number for this particular loop, and then I will have 5 here, so 4 plus 5 is 9, and then I'll have 9 here, right? So this is going to give me 18. Guys, this is the first approach that we have. Once we have got the sum, so at last we can do one thing. We can simply return sum mod 3 double equals to 0. If this is true, then we can return 1, else we can return 0, right? So guys, this is the first approach that we have. And talking about the time complexity of this approach, so first loop run n times because I have an array of size n, and the second loop runs log n times, right? And base is going to be 10. Why? Because we have a number and we keep dividing this number by 10 again and again, right? Until it becomes 1 or 0. So guys, this is about the first approach. So first approach is going to be n log n approach, right? Now talking about the optimal approach. So see, we can make one very interesting observation. Let's say I have an array which contains two numbers. First is x, y, z. This is a 3-digit number, right? And and digits are x, y, and z. And the second number is ab, right? So the first approach basically, which is based on the divisibility rule of 3, it says that if this whole number, like if the number formed by these two digits, which is x, y, z, a, b, is divisible by 3, then all the sum of like digits will be divisible by 3 as well. So it basically means that x plus y plus z plus a plus b is divisible by 3. So mod 3 equals to 0, right? If this number is divisible by 3, then this condition is true. Now what we can do is I can write this number as 100x plus 10y plus z, right? I can write this number like this. This is a 3D standard representation of number. Then I can write this number as 10a plus b, isn't it, guys? Right? So now for this number, see one thing. I can write 99x plus uh, x, right? After this I can write 9y plus y, then I can write plus z, then I can write 9a plus b, right? Why I am writing like this? There is a reason behind this. So now see one thing, I have 99x plus 9y plus 9a, right? After this I have x plus y plus z plus a plus b. I have these numbers. And now what I want is, see, I have to calculate mod 3. What happens when I calculate mod 3, right? So I'll basically do one thing. I'll write this as 99x plus 9y plus a, right? And I can take this as a separate unit plus x plus y plus z plus a plus b mod 3, right? I can take this as separate unit and this as separate unit. And now interestingly you can see one thing, that from this whole number I can take 9 common. So if I take 9 common, then inside this I will have 11x plus y plus a and whole mod 3 plus this is the same thing that I have written here, right? So this is nothing but x plus y plus z plus a plus b mod 3, right? So guys, now you can see that I have 9 here, which is a multiple of 3, and I am calculating mod 3. So this whole value will become 0, right? So this value becomes 0 plus I have x plus y plus z plus a plus b. Why I am writing this, guys? First of all, just understand this, whatever I am writing, then I will explain you what is the intuition, what is the like reason behind this, right? So now you can see that I have got the same thing by doing this particular thing. This means that instead of calculating the sum of each digit, what we can do is we can directly add these digits, right? So we can directly do x, y, z plus ab, and this is the same thing that I'm doing here, right? And ultimately this is also giving me the same result as I have here. So this basically means that what I can do is we can simply calculate the sum of array digits, like array numbers, and then we can check if that sum is divisible by 3. So I can write for like num in array, I can simply keep calculating sum. So initially sum is equal to 0 and sum plus equals to array of, okay, I'll simply write num. I don't have to write array of I, right? Because I don't have any I here. So at last we can simply check the same thing. If sum mod 3 is equal to 0, then I can return 1, else I can return 0, right? So guys, now you can see that this is a very precise and very efficient approach, and the time complexity is going to be O of n for this particular approach, right? Now I hope you have understood how this particular problem can be solved. Let me show you the code quickly, guys. So this is the code. This is the code in C++. After this, we have the code in Java as well, and we have the code in Python as well, right? So guys, in Python, we don't need to take care of like integer overflow, but in Java and Python, make sure you take long here instead of int, right? Because integer overflow can happen here, right? So guys, this is all about this video. I hope everything is mathematically clear to you. So thank you.